हेलो डियर व्यूअर्स, वेलकम टू विजन फार्मेसी। हमारे आज की इस वीडियो में हम देखेंगे सम ऑफ द मोस्ट इंपॉर्टेंट MCQs फ्रॉम बफर सॉल्यूशन। सो प्लीज़ डू लाइक, शेयर, सब्सक्राइब एंड प्रेस द बेल आइकॉन फॉर गेटिंग अपडेट्स ऑन अपकमिंग वीडियोस। लेट्स बिगिन विद आवर टुडेज वीडियो। द फर्स्ट क्वेश्चन इज which of the following is a primary purpose of a buffer solution? The options for the question are as follows. First one, to prevent the pH of solution from changing significantly when small amount of acid or base are added. Second is to increase the solubility of drug. Option number C is to absorb toxic substances, or option number D is to act as a strong acid or base in a solution. So yes student, what do you think? What is the correct answer of the question? The correct answer for this question is option number A, that is to prevent the pH of solution from changing significantly when small amount of an acid or base are added. You know very well that buffers resist change in pH when acids or bases are added, helping to maintain the pH within a specific range, right? So therefore, the purpose is to prevent pH of solution from changing significantly. Moving to next question. The question is, which equation is used to calculate pH of a buffer solution? And the options are A. Arrhenius equation, option number B. Van 't Hoff's equation, option number C. Henderson-Hasselbalch equation, or option number D, that is Nernst equation. So yes, correct answer for this question is option number C, that is Henderson-Hasselbalch equation, right? This equation is used to calculate pH of buffer solution, giving the concentration of acid and its conjugate base, right? So the correct answer is option number C. Moving to next question. The question is, the Henderson-Hasselbalch equation is given by pH is equal to pKa plus log A minus upon HA. What do A minus and HA represents? And the option for this question are A, the concentration of the acid and base in a solution. Option number B, the concentration of conjugate base and acid respectively. Option number C is the concentration of buffer, or option number D is the concentration of water and acid. So yes student, what do you think? What is the correct answer? The correct answer for this question is option number B, that is the concentration of conjugate base and acid respectively. So as per this equation, our A represents concentration of conjugate base, that is A minus, and HA represents the concentration of weak acid. Okay, so the correct answer is option number B. Moving to next question. The question is, what is the effect of increasing the concentration of buffer's conjugate base on pH of the solution? And the options are the pH decreases, B, the pH increases, C, the pH remains unaffected, or D, the buffer loses its effectiveness. So the correct answer for this question is option number B, the pH increases, right? The increasing the concentration of conjugate base shifts the pH to higher value, making it solution more basic, right? Therefore, the pH will increase. Moving to next question. The question is, which of the following buffer is used to maintain pH of blood? And the options are A, carbonic acid bicarbonate buffer. Option number B, acetic acid sodium alginate buffer. Option number C, phosphate buffer. Option number D, ammonium chloride ammonia buffer. So yes, the correct answer for this is option number A, that is carbonic acid bicarbonate buffer, right? So this carbonic acid bicarbonate buffer system helps maintain blood's pH within a narrow range, essentially for proper physiological functions. Therefore, it is used to maintain pH of blood, right? Moving to next question. The question is, the pH of buffer solution is determined by which two factors? And the options are A, the volume and temperature of solution. Option number B, the concentration of buffer component and pK value. Option number C, the solubility of buffer components, and option number D, the ionic strength of solution. So yes student, what do you think? What is the correct answer? The correct answer for this question is option number B, that is the concentration of buffer components and the pK value. Now the pH of a buffer depends on concentration of weak acid and its conjugate base as well as the pK value of the acid. Therefore option number B is the correct answer. Moving to next question. The question is, what is the buffer capacity? And the options given for the question are A, the amount of buffer needed to increase pH by 1 unit. Option number B, the ability of buffer to resist change in pH upon addition of acid or base. Option number C, the maximum concentration of acid or base a buffer can absorb. Or option number D, the time it takes for a buffer to stabilize the pH. So yes students, the correct answer for this question, as per the definition you know very well, the correct answer is option number B, that is the ability of a buffer to resist change in pH upon addition of acid or base, right? So buffer capacity refers to how well a buffer can resist change in pH when acid or base is added, right? So correct answer will be option number B. Moving to next question. The question is, why are buffers important in pharmaceutical formulations? And the options are, first, they improve the solubility of drug. Option number B, they maintain the stability and efficacy of drug by controlling pH. Option number C, they increase the shelf life of drug. Or option number D, they act as preservative. So yes students, the correct answer for this is option number B, they maintain the stability and efficacy of drug by controlling pH, right? So buffers are used in pharmaceutical formulation in order to maintain an optimal pH, ensuring the stability and efficacy, right? So that our formulation remains stable and effective throughout the shelf life. So correct answer will be option number B. Moving to next question. The question is, what is the primary role of buffer in biological systems? And the options for the question are A, to regulate transport of ions. Option number B, to protect enzyme from denaturation. Option number C, to maintain the pH within a narrow range for proper cellular function. Or D, to remove toxins from body. So yes students, the correct answer for this is option number C, to maintain the pH within a narrow range for proper cellular functions, right? So buffers, they essentially in biological system maintain a stable pH, which is very crucial for enzyme activity, metabolic process and overall cellular functioning, right? So correct answer will be option number C. Moving to next question. The question is, which of the following is commonly used buffer in eye drop to maintain pH? Right, we know in various formulation various buffers are being used, and the options are A, phosphate buffer. Option number B, sodium bicarbonate buffer. Option number C, acetate buffer. Or option number D, that is hydrochloric acid buffer. So yes students, the correct answer for this question is option number A, that is phosphate buffer, right? So phosphate buffers are commonly used in eye drops and other pharmaceutical formulation in order to maintain pH which is suitable for ocular tissues, right? So correct answer will be option number A. Moving to next question. The question is, what is a common buffer used in blood transfusion solutions to maintain pH? And the options are A, phosphate buffer, B, that is carbonic acid bicarbonate buffers, option number C, citrate buffer, or option number D, that is acetate buffers. So students, the correct answer for this is option number C, that is citrate buffers. Okay, so these buffers are commonly used in blood transfusion solutions to maintain a stable pH and for preventing of clotting. Okay, moving to next question. The question is, how do buffers contribute to the stability of vaccines? And the option for the question are A, by preventing microbial contamination. Option number B, by maintaining a stable pH which ensures protein stability. Option number C, by improving drug absorption, or option number D is by preventing degradation of adjuvants. And the correct answer for this question, yes, in your opinion, it is option number B, that is by maintaining a stable pH which ensures protein stability, right? So buffer helps in order to maintain the pH of vaccine formulation, which prevents the degradation of protein and ensures stability during storage and transportation. So more accurate answer will be option number B. Moving to next question. The question is, which of the following statement about buffer system is true? And the options are: A, buffer works best when acid and base concentration are unequal. Option number B, buffer can only resist pH change in a narrow pH range around their pKa. Option number C, the more concentrated a buffer solution is, the less effective it is. Or option number D, that is, buffers are effective in both acidic and basic solution regardless of the pH. So yes students, what do you think, which one is the correct statement about buffer? So yes, the correct statement about buffers is option number B, that is buffers can only resist pH change in a narrow pH range around their pKa, right? So buffers are most effective when the pH is close to the pKa of acid or base in the buffer system. So the correct answer will be option number B. Moving to next question. The question is, what is the impact of adding a strong acid to a buffer solution? The options are: A, the pH will increase significantly. Option number B, the buffer will neutralize the acid, causing little change in pH. Option number C, the pH will decrease drastically. Or option number D, the buffer will lose its effectiveness. So yes students, in your opinion, let me tell you the correct answer. The correct answer is the buffer will neutralize the acid, causing little change in the pH. You know that a buffer neutralizes added acid or base, minimizing change in pH and maintaining stability, right? So therefore, the correct answer will be option number B. Moving to the next question. The question is, in a buffer isotonic solution, the osmolarity is designed to be same as which body fluid? And the options are blood plasma, intracellular fluid, cerebrospinal fluid, or option number D, that is saliva. So students, the correct answer for this question is option number A, that is blood plasma. Okay. So buffered isotonic solutions are designed to have same osmolarity as blood plasma in order to ensure safe infusion and prevent cell damage, right? So the correct answer will be option number A. Moving to the next question. The question is, what is the significance of buffer solution in protein formulations? And the options are: A, they prevent protein aggregation and denaturation by maintaining the pH. Then option number B, they increase the solubility of proteins. Option number C, they speed up the formation of protein complexes. Or option number D is they reduce protein synthesis time. So student, the correct answer for the question is option number A, that is they prevent protein aggregation and denaturation by maintaining the pH, right? So buffer solutions are used in protein formulation to maintain a stable pH, right, which ultimately prevent its denaturation as well as aggregation. Moving to next question. The question is, why are buffered solutions used in vaccines? So the options are: A, to increase or enhance the immune response. Option number B is to ensure the antigens remain stable during storage and use. Option number C, to decrease the solubility of the antigens. Or option number D is to increase the osmolarity of the vaccine. So student, the correct answer for this question will be option number B, that is to ensure the antigens remain stable during storage and use, right? So buffer solution in vaccine, they help in order to maintain the pH and stability of the antigen, ensuring the vaccine's effectiveness. Moving to next question. The question is, what happens to the buffer capacity if the concentration of acid and its conjugate base are equal? And the options are A, the buffer capacity is at its maximum. Option number B, the buffer capacity is at its minimum. Option number C, the buffer capacity becomes unstable. Or option number D, the buffer capacity is unaffected. So yes students, what is the correct answer for this? The correct answer for this is option number A, that is the buffer capacity is at its maximum, right? So buffer capacity is maximum when concentration of acid and conjugate base are equal, as this allows the buffer to effectively neutralize both acid as well as base. So the correct answer should be option number A. Going to the next question. The next question is, what one is the application of buffer in drug formulation? The options are A, to control the solubility of drug at site of action. Option number B, to adjust the pH to ensure drug stability and activity. Option number C, to prevent microbial contamination. Or option number D is to improve the absorption rate of drug. So yes students, the correct answer for this is option number B, that is to adjust pH to ensure drug stability and activity. Right, we have already seen that buffers are used in drug formulation to adjust the pH, which helps to maintain the stability and effectiveness of the drug. Moving to the next question. The question is, which of the following statement is true about buffered isotonic solution? And the options are A, they contain electrolytes that help maintaining cell volume. Option number B, they increase the rate of drug absorption. Option number C, they prevent the body from rejecting foreign substances. Or option number D is they help regulate body temperature during drug infusion. So yes students, this is the last question from the presentation. The correct answer for this question is option number A, that is they contain electrolytes that help maintaining cell volume. Buffered isotonic solutions are designed to have same osmolarity of that of body fluids, which maintains cell volume and prevents cell damage during infusion, right? So the correct answer is option number A. I hope you enjoyed the MCQs based on buffer solution. Thank you for watching this video till end. Please do like, share and subscribe the channel. Thank you.